Okay, so here are the answers to the proof practice sheet. If you're still struggling with proofs, I'll try to give you some tips as I go through these. Maybe you can get out that theorem and postulate sheet in front of you so you can be checking them as you go, or open to the back of your book so you can look at the postulates and theorems as I go through these. So one of the first things you should do when you have a proof is make marks on the diagram. So this says given BE bisects angle DBA. So here's DBA. So when I see this statement right here, what goes on in my mind is I know that these two angles are congruent to each other. They may not look congruent, but it doesn't matter. If I tell you that BE bisects this angle right here, well, that's the whole point. The bisector tells us that these two angles are congruent to each other. So I'm going to mark them on my diagram so I don't forget that bit of information. Then the second one, it says angle 3 is congruent to angle 1. So I'm going to mark that on my diagram, that these are congruent to each other. Well, if this has one mark, and these are congruent, I can put one mark here. So now I can see all three of these are congruent to each other. But we have to go through the proof and fill in things and try to find out how that's going to lead to our conclusion, which is that these two lines are parallel, or these two segments. So CD is parallel to BE. Well, if 1 and 2 are congruent to each other, then of course those are parallel to each other, because why? Well, they're alternating interior angles. And remember we talked about when we're trying to prove parallel versus when we're trying to prove angles congruent to each other. So here we're trying to prove parallel, which means we're going to use postulate 11, theorem 3.5, or theorem 3.6. Okay, so let's get back to our proof. Given, so that's what we put in the first one. So we need to write both parts of given. BE bisects angle DBA, and we see that angle 3 is congruent to angle 1. All that's given. Now the next step says that angle 2 is congruent to angle 3. Well, I already know that. I already marked it. How do I know that? That's the question. Why do I know that angle 2 is congruent to angle 3? Well, that goes back to the definition of angle bisector. Right? I told you that these bisect this angle, so this is the definition of angle bisector. Now, why is it not the angle bisector theorem? Remember, angle bisector theorem, they have to have the half in the answer there somewhere. If you look at that sheet, your angle bisector theorem and your midpoint theorem have the half in the explanation. This doesn't have anything about the half. This just has angle 2 is congruent to angle 3. So why do we know that to be true? Definition of angle bisector. Now, what's the only thing, this is substitution property, so what's the only thing in these two lines that I could substitute in for the other? Well, I see an angle 3 here, and I see an angle 3 here, which means I can replace this angle 3 with 2, angle 2. So I have angle 2 is congruent to angle 1. Right? The 3's are the same. If angle 1 is congruent to angle 2 and angle 3 is congruent to angle 2, then angle 2 must be congruent to angle 1. That's substitution property, or you could say transitive property. Okay, well, we already knew that too because I had marked it on my diagram. But now we're just explaining why we know this is true. And if angle 1 and angle 2 are congruent, well, look at what we're looking at here. Right? That's my letter N, backwards N, or my Z on its side. So the zigzag here, that's alternating interior angles. These are alternating, they're on opposite sides. They're on alternating sides of the transversal, and they're interior. They're on the inside of my parallel lines. So these are alternating interior angles, but I'm proving that these two lines are parallel. So is it alternating interior angles implies parallel? Or is it parallel implies alternating interior angles are congruent? Well, it's this. The fact that they are congruent to each other implies they are parallel. So that is, I look at alternating interior angles implies parallel, and that is theorem 3.5, which says alternating interior angles implies parallel. So these alternating interior angles lead me to conclude, that's what implies means. Remember, this is our conclusion. This is our hypothesis. This is our conclusion. but they're parallel lines. Okay, the second one. Again, if you start off with the tip of look at this given information and now mark your diagram accordingly. So I see that BE is perpendicular to DA. If BE is perpendicular to DA, in my brain, I know that that's a 90-degree angle right there. So I'm going to mark it. This tells me that these two segments are perpendicular to each other. And CD is perpendicular to DA. Again, I'm going to mark it. I know that these two are perpendicular to each other. So therefore, this is 90 degrees. So now, what do I do? Step number one, always write your given here, unless I tell you something otherwise. So BE is perpendicular to DA, segment CD is perpendicular to DA. So what does that lead me to believe? Well, let's read Theorem 3.7. Theorem 3.7 says, in a plane, two lines perpendicular to the same line are parallel. So this theorem says two lines perpendicular to the same line are parallel. So two lines perpendicular to the same line must be parallel. So therefore, what can I conclude? I can conclude that segment CD is parallel to segment BE. These two line segments are perpendicular to the same line segment, which is DA. Therefore, these two line segments must be parallel. That's what that says. Line segments is the same thing. We can make these go on forever and ever. So you can substitute line segment for line. Line segments can also be parallel to each other. And if these two lines are parallel to each other, then does that lead us to conclude that angle 1 is congruent to angle 2? Well, sure. Look, it's just what we did up there, but it's the opposite. This time we have the parallel lines that imply alternating interior angles are congruent. So here we have this, and we have this here. So we know these are congruent to each other. Why? Because they're alternating interior angles. So angle 1 is congruent to 2. So that is theorem 3.2. Right? The parallel lines make us know that these angles are congruent, as opposed to the one above it. Right, where it says that the congruent angles imply parallel lines. It's the opposite, it's the converse. Okay, number 3, I have a mistake there, I missed a step. We need a couple steps in here. This is the proof from the class, so really it gets kind of messy in there. But I forgot this step where I had to add this angle. So anyway, don't do step number 3. There's not enough steps in there to do it. So let's ignore it. Proof number 4. Okay, again, let's follow the same pattern. Look at the given and mark the diagram accordingly. Segment BE is perpendicular to segment DA. So I'm going to mark this corner angle to show me that that's perpendicular, meaning that angle is 90 degrees. Angle 3 is congruent to angle C. So I'm going to mark these so that I know both of these are congruent to each other. Okay, let's go through the proof. Angle 3 is congruent to angle C. That's given. CD, so segment CD is parallel to BE. Well, there's only 3 different ways, right? There's only 3 different ways we can identify that two lines are parallel to each other. It is postulate 11, corresponding implies parallel. It's theorem 3.5, alternate interior angles implies parallel, or theorem 3.6, same side interior angles imply parallel. So there's actually a few others in there with perpendiculars, but in this case, look at angle C and look at angle 3. These are both bordering up on the transversal and the parallels, the ones we're trying to prove parallel, right? So we're trying to prove that these are parallel. So the only two that associate those together are angle C and angle 3. So these are what? These are corresponding angles. That's my F right there. Sorry, that got a little messy. That's my letter F right there. Right? It's a backwards F. right? It's a backwards F. These are my corresponding angles, right here, right here. So that is, two lines are parallel, so we're looking at postulate 11, right? So postulate 11 tells us that corresponding angles implies parallel. So corresponding angles implies parallel. That's postulate 11. And then what else was given? Segment BE was perpendicular to segment DA. Well, what did I mark right there immediately? I marked that 90-degree angle in that corner. How did I know that? Why did I mark that angle? I marked that angle because of this statement right here. And what does this statement say? The statement says the two line segments are perpendicular. So therefore, how did I know that was a 90-degree angle in that corner? It's because of the definition of perpendicular lines. The definition of perpendicular lines tells us that all four of those angles when they intersect are going to be 90 degrees. Therefore, I know that's 90 degrees in that corner. So why do we know this? Because of the definition of perpendicular lines. Okay, moving on. Angle CDE is congruent to angle BEA. Why do we know that? Well, again, going back, we have CDE and BEA. Look at that letter I'm making right there with my purple pen. What letter is that? Is that a Z or an N or a U or an F? That is an F again, right? That's, oops, a little extra, not an E, but an F. That's an F. And the F has these corresponding angles right here. So I've already said that these two are parallel to each other. Therefore, is this true? Yes. Why? Because those are corresponding angles right here. So these must be congruent because these lines are parallel. And so where does it say that corresponding angles are congruent given parallel lines? Well, that is postulate 10. Right? If we know two lines are parallel, so it says if you have parallel lines, then that implies corresponding angles are congruent. Parallel lines implies corresponding angles are congruent. So therefore these must be congruent because these were parallel up here. Well, if these two are congruent to each other or equal to each other, and I'm talking about substitution property right here, then I'm looking at these lines and trying to figure out what I'm going to substitute into what. Well, right here I see a BEA, right here I see the fact that CDE equals BEA. That means I can substitute that in there. So the measure of angle CDE must equal 90 degrees. Why? Because I've just substituted in CDE for this BEA after I discovered they were equal to each other. And if CDE is 90 degrees and I put that symbol right here in the corner, then what must be true of these two segments? They must be perpendicular to each other. Why? Coming back to this again, because of the definition of perpendicular lines. Okay, final one, we have to be quick. Angle 3 is supplementary to angle 5, so we're going to write that here for our first step. So what does that mean if they're supplementary? Well, it means they're 180 degrees if we add them up. So this is the definition of supplementary angles, right? If I tell you they're supplementary, the only reason I'm doing that is to get this information. The next reason is vertical angle theorem. I only see one pair of vertical angles, so this must mean that angle 3 is congruent to angle 4. Substitution. Well, this is 3 plus 5 equals 180. 3 equals 4, so therefore the measure of angle 4 plus the measure of angle 5 must equal 180. That's substitution. Then my definition of supplementary angles, that would then tell you that angle 4 is supplementary to angle 5. If they equal 180, they must be supplementary to each other. And then finally, that allows us to conclude that segment BD is parallel to EF. Why? Well, if angle 4 and angle 5 are supplementary, this is the U right here, so that's the SSI. Right? So they're same side interior angles. So that's theorem 3.6, which says same side interior angles implies parallel lines. Right? So that's the reason. Angle 4 is supplementary to angle 5. Right here, this is the U, same side interior. They're supplementary. There you go.